Hello, Assalamu alaikum. Can you hear me? Hello, Assalamu alaikum. Can you hear me? Sorry, I can't hear you. Let me know if you can hear me.
Sir, can you hear me?
I can hear you. Can you hear me now?
Yes, I can hear you. First,
Okay.
I think you couldn't hear me.
Now, I was speaking on it, but I think it was a lagging
Yeah, maybe.
reactivity series. And sorry for yesterday, we were having, you might have heard about this issue, but we were having last 2 to 3 days, we were having internet issues here. It was at that
Oh,
time, and it was so much fluctuation that class was not getting connected. We can do a
oh,
class or day after tomorrow, whenever I will give you the options. And if you are available, then we can put a class.
sure. Sure,
So
sir.
we reactivity series.
Yes.
So can you please check what was our last title?
The last title was the reactivity series. Reference number 11, you gave me a table and understand how metals can be arranged in a reactivity series based um, on displacement reactions.
So have we copied? You have copied it, right?
Yes, I've made the table.
Now give the new heading for today. The first heading, displacement reactions.
Okay. Done.
Can you tell me what happened here?
Um, displacement.
Hmm. So what we can deduce about the word displacement? What is displacement?
It's when An element can be displaced by another.
Very good. Sodium has displaced copper. First copy this.
Okay.
First copy this. Have you copied it?
Yes. Yes, I have copied it down.
So sodium has displaced copper. Why sodium has displaced copper? How come sodium can do this thing? Because sodium would be more reactive. Sodium would be more reactive than copper. Sodium would be
More reactive.
more reactive than copper. So we put our a more reactive metal will react more strongly than a less reactive metal. A more reactive metal will displace the less reactive metal during a chemical reaction. So you have to copy this thing.
Yes, sir, I have wrote it down.
So displacement is a reaction in which one which is more reactive will be able to displace which is less reactive. Have you done redox, oxidation reduction in your school?
Yes.
Okay. Now copy this yellow bracket.
Okay. Yes, sir, I have wrote it down.
Now give a new heading. Displacement reactions in aqueous solution. What do you mean by aqueous?
Water, liquid,
Yes, water. Very good. Aqueous means water. So many metal salts are soluble in water. The famous example is sodium chloride. What is sodium chloride? In our home, sodium chloride is the salt. Sodium chloride is a salt. When a more reactive metal is introduced to a solution of aqueous salt, the more reactive metal will displace the less reactive metal in the salt. So what is our concept? The word aqueous means soluble, aqueous means water, something is dissolved in water. So we have an aqueous solution of copper sulfate with solid block of aluminum. When a block of aluminum is added to the solution, the copper is displaced, the solution turns blue to colorless. So we have two concepts to understand that copper solution is typical blue. It's a very neat blue color, deep. And when you add aluminum here, the blue color will disappear. So we have two concepts to remember. What's the first concept? When a more reactive metal is introduced to a solution of aqueous salt, it is capable of displacing it to the less reactive one. So what's the rule? The same rule as we discussed before. More reactive can displace less reactive. What's the rule? More reactive can,
displace less reactive.
yes, more reactive can displace less reactive one. This is the rule. More reactive can displace less reactive one. So after giving the heading, you have to copy this one. I'm just coming. I have to say namaz here. I'm just coming in a minute. Okay.
Okay.
Now we put the concept iron is a metal. Acha, rusting is something which is very common in our life. When you are in our common life,
Mm-hmm.
we see this feature. Rusting is our in our common life. It's common when especially iron is left for some time in open environment. We see iron begins to rust. Rusting occurs when iron comes in contact with oxygen, in contact with water. So iron, in that case, gets an oxide layer, that's brown color layer. And this actually, the problem is there. This layer is not sticky. With the passage of time, it keeps on increasing. And iron, look at this iron big nail, iron gradually rust. So formation of iron oxide is a form of rusting for iron. Have you copied it? Have you copied this?
Yes.
Good. Now remember this concept, write under it. For example, write under it that, for example, when aluminum is added to a solution, for example, when aluminum is added to a solution of copper sulfate, when aluminum is added to a solution of copper sulfate,
Mm-hmm. Then.
the blue color, becomes colorless. What do you think? Rusting is good or rusting destroys iron?
It destroys.
Very good. Rusting is very dangerous, and due to rusting, iron deteriorates. And that is why people say iron rods should not be exposed to environment, oxygen, water, keep them dry. So now you have to copy this script.
Okay.
Have you copied?
Yeah, I'm just writing down the equation.
Iron plus water plus oxygen
Yes, sir, I wrote it down.
rust is a huge concern for structures that need to be both strong and watertight, such as ships. So rusting is a problem. Why rusting is a problem more serious for ships? Yes, rusting
Because
occurs more effectively when iron is in
the ship will get sinked.
water. Hmm. Yes, please go ahead. Why rusting is a major big concern for ships? Definitely
Um,
because there is water.
because the ship will get sinked.
No, no, that's all right. But
Yeah.
ships are always in contact with water. As the ships are always in
Mhm.
contact with water, is it right that that will be a case of always a chance of rusting for ships?
Yes.
Good. Now give a heading, preventing rusting. There are two methods to prevent, you must have seen these two methods at your home also. People paint it. Some people put grease on it, and some people keep them dry. Metals, metal structures are always kept in dry conditions, and
Yes.
we can have a plastic barrier, we can have a grease, we have anything which keep them dry. Rusting is also a topic when we will do electrolysis, electroplating. This is something you have seen also. I hope you have seen it. That some people put a golden coat on it or a silver
Yes.
shine coat on it. If you coat it, if you coat it with anything which is shiny, like and less reactive, like gold, like silver, like aluminum, you can prevent iron from rusting. Why iron is used so much? Actually, iron is exceptionally strong. Iron is exceptionally strong. So whenever we come across this issue, whenever we come across this issue that we are dealing with iron, so iron is extraordinary strong, but rusting destroys everything. So we can put a barrier, like we can cover it by a plastic layer. we can put we can put oil on it. We can put grease on it. We can also keep it dry, and we can put another metal on it. If you coat iron with another metal, if you coat iron with another metal, we call it a term. Look at this term. Read this underline. What is the term is?
Sacrificial protection.
Sacrificial protection. So suppose you coat silver. You coat silver on iron. This is a sacrificial protection. You can protect iron. You can protect iron from other things, and like coating silver, coating gold. So this is called sacrificial protection. Now, what are the two methods? Look at these two brackets. What are the two methods? Give the heading preventing rusting, and you have to copy these two yellow brackets.
Okay. Yes, sir, I wrote it down.
So can you repeat what are the two methods of preventing iron from rusting?
Coating the iron with a barrier or using sacrificial protection.
Right. For example, this iron is rusted. So if we, in the start, now it is rusted, so it's gone. But what if we try to protect it? We can cover it by a plastic. Let's say we can put it by a plastic layer on it, or we paint it like nowadays people paint it. If you paint it or put a plastic layer on it, you can protect it, and you can keep it in a way, you can keep it in a safe position, and this can prevent further rusting, or rusting can be stopped from the start also. Look at this example and you can answer this question, why these people are painted it so dark green, the railing. Look at this really. Why they have painted it so sharp green?
To cover the metal
For what?
so it doesn't get rusted.
Yes. So this is the good answer. This is a practical example. Another way to protect against rust is to coat the iron with a more reactive metal such as zinc. This process is called galvanization. So you coat iron with another metal, just like hiring a guard which can protect you. This is a way which is called galvanization. You have here, you can coat it. You can coat it with more reactive metal. Zinc is more reactive than iron. So we have coated zinc on iron. So now you have to you have to copy this bracket.
Okay.
Have you copied it?
Yes, sir.
Good. Metals and redox reaction. This is our next heading. Give a new
Okay.
heading, redox. Metals and redox reaction.
Done.
Metal and redox reaction. Now, I want to revise with you this topic. Redox. We haven't done it here, but you have done it in school, so we should have a
Hmm.
quick review on this. Redox. This word redox is actually a combination of two words. What are the two words? Reduction. The term redox means reduction and oxidation. The term redox means there are two terminologies together, reduction and oxidation. What is reduction? What is oxidation? First, copy this screen.
Done, sir.
What is reduction?
Loss of oxygen
Good. And the second,
and gain of hydrogen.
right. And the third, gain of electrons. This is another, we are making another sheet which has to be memorized. Some sheets are like strong memory sheets. Redox is also a topic which comes across the chemistry everywhere. So now you have to copy this. If you if you reverse the concepts of reduction, you get oxidation.
Yes, sir, I wrote it down.
Okay, good. Loss of oxygen. What's the meaning of loss of oxygen?
That it loses oxygen.
Yes, it loses oxygen. Oxygen is present, but we somehow remove it and we take out oxygen from something. If we take out oxygen from a substance, How it is reduction? And how this second equation is reduction. Now look at these examples. Copy these examples and answer my question for every equation, how it is reduction. So please copy it.
Okay.
Yes. Now, can you please answer? And also, can you help me to balance the first equation?
Okay. So the first one will just have it. We'll have to put to balance, we'll have to put 3 in front of KC and then another 3 in front of KCL and then a 3 in front of O2.
2 KCl, it is 2 and 3O2,
Yeah.
like this.
No. Um, yeah, yeah. Yep, like that.
Now, how it is reduction?
Because um it's losing oxygen.
Hmm? Losing oxygen, right?
And the second one is gain of hydrogen
Very good. And how the third equation is fitting in our discussion today?
because of the gain of electrons.
Gain of electron, right? Look at the first example. How this example is fitting here?
It's gaining oxygen in the first one,
Yes.
and the second one is loss of hydrogen.
Hydrogen is going out, so loss of hydrogen. Now, copy these examples.
Yes, I've wrote it down.
So this is a contrast between oxidation and reduction. Together we call it redox. Now we have reached this point. Oxidation can be defined as loss of electron. It can also be defined as gain of oxygen. Sodium is oxidized to sodium oxide. Now you have to copy this yellow bracket. Sorry, you have to copy this. Have you copied?
Second, hear me?
Okay, have you copied it? Are you back?
Yes, I'll just copy this down.
Okay. You have copied it, right?
Uh,
No, no,
this
copy
one?
no problem. The
Yeah, I
the yeah.
think, yeah, I've copied this one down.
Good. Achha, now tell me how this is called, how we are taking it oxidation.
How is this oxidation?
Hmm? Yes. How
What's
come
the
it is oxidation?
because it's gain of oxygen.
Right. Gain of oxygen. Now, what is an oxidizing agent? In our course, these were the terminologies. So if a substance can oxidize something, it is called an oxidizing agent. What is an oxidizing agent? A substance which can oxidize something. A substance which can oxidize something is called oxidizing agent. An oxidizing agent is itself reduced. And so what is the concept? Now you have to copy this.
Okay. Yes, sir, I have wrote it down. Sir, I have wrote it down.
Yes. Now give the heading. Sorry, heading is there already. Reduction. Now look at this example and you first copy this example and then I will ask you that what is it? How he's saying reduced. First you copy this.
Okay. Yes, sir, I have wrote it down.
So how come it is reduction?
Because it's gaining oxygen.
Gaining oxygen.
Wait. or loss of um
It's a, can you see it's losing oxygen? Look at this
yes,
arrow,
yes,
oxygen, and now there is no oxygen.
yes, yes,
It means iron oxide has lost oxygen.
yes.
So we stop here, and we will inshallah continue in our next class. Thank you.
Okay, Allah Hafiz, sir.